scientists at Special Operations Command Center and Central Command to conduct global data-driven social science research to inform strategy for countering extremism and assessing military operations. This afternoon is here to talk about trustworthy AI. Ian, thank you very much for coming along today.
Thank you very much. And are there slides? Yes, it's great to be here. Thank you for hosting me across the pond. I'm with Accenture Federal Services, so I lead our AI delivery for the U.S. federal government for Accenture. And as was mentioned, I'm a scholar soldier, so I spent 20 years in the Army. I was then a professor at Johns Hopkins University for a number of years, and then joined Accenture. And so I kind of have a different perspective, looking at it from, first military service, then academia, now industry. So I want to talk about what's beyond the algorithm. We spend a lot of time talking about responsible AI from the perspective of the algorithm. So let's just make sure we're on the same agreement of what that definition is. And an algorithm is basically just a set of finite steps to solve a problem, usually a math problem, usually requires some repetition. And so when I see that and I hear all the attention about responsible AI and responsible algorithms, I just look at a simple math problem and I ask, what's ethical or responsible about that? Right? I would argue there's really nothing responsible or irresponsible about that equation until we start saying 11 of what, 31 of what, and what does that equal? And so it's really the context. Well, I'll go back the slide here. It's really the context around that matters. And so we can talk about all the different types of algorithms that you may have heard of. Brute force is something that's very computationally expensive, very time consuming, has a very high carbon footprint usually, right? But will usually get to a great answer. Whereas a greedy algorithm is something that will really be good at getting an answer that's maybe locally optimum, but it's maybe not the best answer, but it's a lot more cost effective. And we can talk about these trade-offs. But then when we start talking about the philosophy behind it, I like to bring up the example of Simpson's paradox. I used to use this when I was teaching at Hopkins. So what you see is Professor Robinson. She wanted to get tenure in the math department at Berkeley in the 1970s. And they were concerned about the threat of gender discrimination because all departments admitted men to graduate programs at higher rates than women in the university. But then they brought up the point that the university admitted women at higher rates than men. So the question is, who's right? Does that exist, right? Is there gender bias or not? Well, let me give you a little bit of numbers or some data to back this up. If I have two departments, just for illustration, and I say Department A admitted 0 of 1 female applicant, and they admitted half of 100 male applicants, and Department B admitted 70% of 100 women applicants and all of the male applicants, you can see that the percentage of women that were admitted is less than men. But when I add them all together, the percentage of women that are admitted is higher than the men. So who's right? Where is gender bias? Does it exist? Does it not exist, right? These are the philosophical questions that are beyond the algorithm. It's not about the math. It's about how you've set up the problem and how you've defined it. And oftentimes the answer to that question lies outside of the algorithm itself. So context matters quite a bit when we're looking at these problems. I'm going to turn your attention to maybe a problem that's a little bit more relevant to military operations. And what you see here is a network of extremist content. This is data. This is over 10 years old now. But each of the dots represent an online forum. And the question is there extremist radicalization going on that's recruiting people for Al-Qaeda at the time or not? And so in this particular program, it was a $26 million a year program to counter online extremism. And about $4 million a year in proportional labor out of this $26 million was to assess, is a forum pro-Al-Qaeda, pro-U.S.? So it's green if it's pro-U.S., it's red if it's pro-Al-Qaeda, it's yellow if it's unassessed. You see a lot of yellow, right? And you also notice that in that little cluster to the upper center, there's only a couple dots. Like we've put a lot of dots down here in the cluster right below it. And above it, not very much. We haven't even allocated our resources in an intelligent ISR plan across that space. And so I said, you know what, I can automate that. I can create a machine learning classifier, even though it was like over 10 years ago. And I created a classifier, had 64% accuracy. And everybody's like, Ian, your algorithm sucks. It's like flipping a coin. And I'm like, it's double digit better than flipping a coin, thank you. But, you know, nobody liked it. So would you make operational decisions based on 64%? Well, I asked the question, how often do the humans agree on their assessment of pro-Al-Qaeda, pro-America? Seems like a simple enough question. 68% of the time. So now you're spending $4 million a year to get a 4% marginal improvement while neglecting why 32% of the time, almost a third of the time, humans can't agree on the outcome. And so as you start looking at it, well, what happens if somebody says something, I don't know, negative about the president of the United States? What if that president is Donald Trump versus Obama or Biden? Does that make it pro-America or anti-America? Does it make it pro-Al-Qaeda? Is that not applicable? There's always going to be these edge cases or use cases where it's very difficult to make the decision. Those are the things that the commander needs to be able to be aware of and be able to weigh in on that policy before decisions are made. And so what are we doing to measure the consistency, not just of the AI, but of the human process? And then where does AI improve? And so I've already said that. So here's another example with object detection. This is an early case from Project Maven, and this isn't Project Maven because I can't share that data, so we just did a clone project of Project Maven using open data. But you see good annotation in the upper left where there's fairly tight bounding boxes. This is to identify vehicles, people, bicycles. And then you see sloppy annotation below where they see that the car and the person, there's overlap, they're not as tightly defined, right? So how well we do that annotation task is very important to the machine learning outcome. So we introduced this idea of annotator vitality. So if I have 4 annotators that are annotating these images and I look at that overlap to see how often do they agree, and I find one of the annotators is not like the others, and I drop their data from the problem, you'll see that there is an increase in precision, which means when I say it's a truck, it's a truck. But there's a degrading of recall. Did I find all of the trucks? Because I've thrown away the data. Here's the problem. When we do pilots, we weigh these things as equal, right? We weigh them the same for an F score, and that's how we weigh the pilot. So you can get a lot of cheap data and you can artificially boost your F score, but with that inconsistency, right, you can't recover from that. That's technical debt you're incurring on day one. I will get more data in time, but if I don't get the consistency right up front early, I have technical debt I can't recover from. So this idea of being focused on precision is very important in your quality. So not just from responsibility, but fiscal responsibility in how you deliver a program. Here's another example is we deliver an at-scale program for assessing federal disability claims. So in the US, if you were diagnosed with pancreatic cancer and had 3 months left to live, it will take you 4.5 months to get your medical disability benefits. So you won't have insurance, you won't go to the doctor because you'll be worried about the decision and what that puts your family in. It's really horrible. But I can deliver an AI system that can ingest millions of pages of medical records a day, and it can approximate what the outcome is with about 97% accuracy in seconds. I think we say minutes, but it's really seconds, right? Pretty accurately. So we can get the benefits, yes benefits, to people that deserve them. Well, this is an interesting issue in implementation of how do you implement the AI. We don't necessarily want to have a machine saying no, but maybe we want to have a machine saying yes to get people their benefits before they die. Maybe not doing that is unethical. And one of the particular cases was our hypertension classifier, which was only performing at 25%. So what we recognize is hypertension is comorbid with a lot of other illness. So if you have heart disease, the doctor doesn't necessarily think to annotate hypertension. So how did we improve the accuracy of the classifier? Well, we didn't do it by doing better math or cleverer algorithms. What we did is we had nurses go back and re-annotate data to say, yes, this is hypertension. Yes, this is hypertension. And then we feed it through the system, and we now have 95% accuracy, right? By treating the way the data was labeled in the first place. So when we look at the algorithms, right, yes, that's the algorithm behind the solution. We can look at the complexity, the time and cost, the feasibility of the algorithm, but let's also talk about how we operationalize data. It's a socio-technical construct. So the context matters. Are we using proxies for the data? Is that good enough? Do we even trust and believe in the data? When I was in Iraq, I was asked by the director of operations when we redeployed combat forces along Route Tampa out through Kuwait, was the adversary targeting us more? That was my question. So I said, okay. I went to the database at the time, and there's like a Route Tampa. So I just said, I want to pull all data of significant activities plus or minus 50 meters off of Route Tampa. And I did a backwards statistical process monitoring. So it's a change detection, just going backwards in time. And I concluded generally no changes, except in Mosul, about 3 months prior to the withdrawal, there was an uptick in enemy activity, right? So I go and I present it to the J2 at the time and the director of operations, and they say, well, wait a minute, what was your data? So I told him like I told you, and he says, well, what if it was 51 meters off the road? It wouldn't be in my data set. Well, what happened if the road didn't quite match up with the line? Well, then it may not be in my data set. You need to check all those data points. There's over 8,000 data points in this time period, right? At a cost of $350,000 a year for a data scientist, 3 of them taking a week, is a very expensive task to look at every single data point. And I don't think it'll affect the answer. No. You have to do that. So we spent a week going through this problem, and we came back, and you know what the answer was? Generally, there was no change in activities, right, going back in time, except in Mosul about 3 months earlier, right, there was an uptick in activity, right? So we just wasted a week and a bunch of money doing that. There's a couple issues with that. One is oftentimes a representative sample of data is great for decision-making and insight, and you do not have to waste time and money and expense getting all of the data for a predictive analytic. Now, certainly, if I'm doing invoicing, if I'm tracking the number of soldiers on the battlefield, if I'm accounting for weapons and munitions, right, then I'm doing an accounting task. I want to be highly normalized. I probably don't want a data lake. I probably want to have more of an Oracle, like highly structured solution, right? But if I'm doing decision support, I can get faster decisions with more operational relevance if I think through that a little better. But you have to trust and believe in the data, and you might want to have that conversation before you go through the analytic effort. Right? So here's another project that I've just concluded recently, and this is around organ donation. So in the US, 27% of viable organs for transplant are thrown in the trash. Wow, 15 people a day die on the wait list. In the UK, it's only 12%, right? What's the difference? Well, it's how policy gets materialized into operations. So, there's kind of 3 trade-offs: equity, utilization of the deceased donor organs, and medical outcomes. And people think that there is this algorithm of you're matching the physiology of the organ to the physiology of the patient, the best one. That's not what happens anywhere, right? That's just not how it works, right? What happens is, if you've been on the wait list for a long time, it's your turn. We bias in the US towards equity. So if there's a viable organ that comes out and you've been waiting a long time, you get the right of first refusal. But guess what? If you've been on the wait list for over 5 years, do you want a mediocre organ that's like a 50% organ? It's a perfectly viable, it's better than half the organs that will be available this year. Do you want that? No. You want an A+, awesome, 90 percentile organ. So you say no, and then the next person says no, and the next person, and by the time it gets to somebody that says yes, cold ischemia sets in, and it's no good for anybody. So the UK actually biases that, or bypasses that, by saying, hey, this is an at-risk for discard organ, I'm going to cut the line. And everybody criticizes medical practice in the UK and say, well, what about the person right in front of them in line? That's not very fair. But they have a 12% discard rate instead of 27%. So how do we solve this problem with AI, or how do we look at it? Well, the first thing is to understand the problem. I'm not going to do that. Yes, I can do some exploratory data, but what I need to do is send out probably some anthropologists to go out and listen at what happens amongst nephrologists and organ donation, surgeons and transplant centers, and understand what the potential problems are. And they come up with a lot of different ideas. So now you have all these ideas, we have to refine the concepts and have some designers say, well, what kind of tools, understanding some cognitive psychology and decision-making can we do to address the issue, right? But here's the thing with data science. Let's put the science in data science, right? If the scientific process involves looking at the world around you and then forming a hypothesis, Then you collect data and go on. If you don't have that important step of forming the hypothesis, you're not following the scientific method. You're just shopping for data to confirm your biases, right? Let me just say that again. If you do not have a testable hypothesis and you are not prepared to be wrong, you are not scientific, period. You are looking for confirmation bias. That's what you're doing. So we stop and we take all these ideas and we design a systematic design of experiments where I can systematically alter different visualizations and different methods, and I do a study and a mock example to see how this might move behavior. Very important in organ transplant because I can't do harm. And what we find is some of the ideas work, some of the ideas don't work, so we're able to refine those concepts further. We're able to build out a pilot. One of the interesting things is that if you tell a doctor that accepting this organ will give your patient 10 years of life, a lot of them will say yes. But if you flip it and say, refusing this organ will cost your patient 10 years of life, same data, just flipping it, you will almost eliminate the optimism bias and you will get better decision making. And so we do that and we pilot it at 6 transplant centers over the course of a year, and we were able to see that yes, it indeed worked. And then we went at scale in January. We expect to see as many as additional 5,000 transplants this year as a result of that AI-enabled system to improve human decision making. Now the question is, when we start talking about decision making, and I think one of the gentlemen earlier today was saying, I feel quite comfortable in answering to our robot overlords, what I would say to him and to you is, for me personally, I do not want a human making my medical decisions. I would much rather have the robot do it because it's it's free of bias, right? Or it's much less bias in the process. So when you look at this another way, right, I think it's important to break down AI concepts and problems into how we understand the problem, refining the concepts, how we measure that. And in this case, we had 2 off-ramps. So when we're doing an investment in an AI system and we're going to validate the concepts, there needs to be an exit criteria. Nobody bats 1,000. That's an American analogy for baseball, right? When you get up to, I'm sure in cricket, you don't always hit the ball every time, right? Right? Or you can go to rugby. Nobody tries on every possession, unless you're really, really good. But the idea is nobody's going to be perfect. If you're looking for perfection, you're either not innovative because you're not reaching far enough, or you're maybe a little dishonest in your evaluation of the process, right? You should expect to have failures, and you should then design for an exit criteria before you've spent a lot of money to say, is this working? If not, let's be prepared to stop. Let's pilot it, and if it doesn't work, let's be prepared to stop. Then we can scale. We need to understand what people do. We need to learn why they do it, and we need to listen and observe. There's an example of military maintainers where they were having problems fixing a particular military system, and the anthropologists found that they were texting their buddies in another unit with, how do I fix this, right? Which is a huge operational issue, right? How many of you are like ready to throw these guys in the brig and say that's like totally unacceptable, natural reaction for a military officer? But then the anthropologist is like, wait a minute. How does the weapon system get fixed, right? What is wrong with the training, the communication channels, the documentation, if we can't resolve this? And so by definition, most of the problems that exist in a military organization will never be reported to officer level leadership because you have that reaction of throwing them in the brig. How do you have understanding and really get to the root cause of the problems and in an anonymous way report that back and let you react to it so you can get more mature solutions? Here's a similar example. There was a requirement to mail COVID test kits to everybody in the US, right? And so in some places, addresses were resolved pretty easily, right? Like a great example would be if you were a college student in a dorm in Florida and you asked for a test kit, that's great. Somebody else in the dorm asked for a test kit, great. But if you're in California and you asked for a test kit, the first student got it, and then everybody else in the dorm, oh, you've already gotten one to that address now, right? So there's about 300,000 requests for missed service. And so we thought that overwhelmed the ability for the service center to respond. So we say, hey, we'll come up with a machine learning solution. And it basically takes the data, it does a natural language processing model, it kind of identifies these 5 categories. It was about 84% performance accuracy, to which I said, how often do the postal workers agree? And 84% of the time they agreed. So, we're about as good as you can get, right? But what's interesting is, what do you do with that, right? At the end of the day, you're not trying to figure out 5 different categories of address resolution issues. You're either going to mail it to somebody or you're not. And so when you actually collapse it to that, the performance immediately boosts, right? Because there's only 2 categories instead of 5. But then you can focus solutions, address resolution, where it makes sense, and you can get to a better answer. And the other thing that I would point out is that when you look at who was affected by the issues, it's disproportionately low-income people. So the failure to adopt AI is actually the unethical choice here and the irresponsible choice, because when you rely on manual processes, it's not status quo. It probably is harming the most disadvantaged portions of our population. And this whole concept of risk-based AI is horrible, because you know who's advocating it the most? Russia, China. Does that not ring a bell of alarm to anybody? Because when the West is then in fear going to adopt risk-based regulations, it inhibits adoption. It basically keeps us from actually adopting and advancing in AI and having parity with our adversaries. And it does not produce ethical results at the end of the day. So we should be looking at a human baseline approach where we understand where our current system is, and if AI can do a better job at getting services to people, we are irresponsible to not adopt AI. So just to kind of lay this out, I think there's 4 levels or 4 approaches, right? 4 steps here. We have the requirements, which is how do we understand the problem? Are we looking at the edge and understanding the users? When I was in Special Forces, we have to enter data into a SODARS report, and Special Operations Command would aggregate all of this data up and make their acquisition decisions. But I was a very immature captain, so I didn't do it until my commander would yell at me to do it. And then I would figure out whichever sergeant, made me the most irritated that day, and I would tell him to go fill out the report. And he'd say, how do I do it? I'm like, I don't know, I don't care. Just make it go away. Meanwhile, all the operational relevant stuff that I had from the mission was on a floppy disk on a desktop computer, and I would share it with my other team leaders until one day they hired a big consultant to come in and break data silos and get all of the disks and aggregate all of the information together so they could inform doctrine. But guess what? I never got out of the SODARS reports. Anything, ever. It was just data in, because it was a hierarchical C-suite tool that didn't benefit me at the edge, so I didn't value it, and I did not put anything into it. If we don't go out to the edge and understand the users and give them incentive to enter data, we will have problems. We cannot top-down govern. How do we observe those issues? How do we let people react to those different viewpoints and continually iterate? When we go to operationalize the data, it's a socio-technical construct. Have we got buy-in before we begin investment in a project that this is a suitable data source? Do we understand when we can use a representative sample, when we need to use all the data? Are we repurposing the data from its original intent? What does that do for us? The algorithms are the easy part, actually. And then how do we implement the solutions at the end of the day to inform decisions? And so we call this the ROAD methodology, which is a silly acronym, I know, especially when we put a little road picture there. But why do I do that? Because my data scientists can remember it. It's an acronym that they can remember. When you start dealing with a lot of these other formats like CRISP-DM or all the DMM or right, when you look at all these things, nobody ever remembers what the acronym is or the steps. But with ROAD, you can quickly identify before you begin a project, have you properly scoped the requirement? Have you operationalized the data, which not only fits my acronym, but it also has this idea that data is just not fine in its natural state. You have to do things, you have to think about the data. That's usually your most important step. You analyze it, and then what decision are you prepared to make? If your commander is not willing to make a decision before you've touched the data, why? What do we need to redefine the requirement? Do we need to relook at how we've operationalized the data? Do we need to explain the algorithm? If you are not prepared to make decisions before you start the project, you're wasting cycles or shopping for confirmation bias. Be prepared to kind of look at what you are willing to do or not willing to do before you start the process. So I think we're out of time for this. I'm concluded, I think. And so it's a pleasure, and I think I will be around for what is it, drinks and nibbles? Is that what we call it?
That's all right. Yeah, fantastic. Let's gently in.